Good morning, everyone. So, welcome back to the class. I hope your tests went well and you have done reasonably good. Test one of all subjects over. Hopefully, for algorithms also, it went well without much of a problem. Well, good morning. And just I was in the morning wondering that how many of you use social networking? I'm sure most of you must be using one or other. Of course, I remember around 10 years back, Facebook when became so popular, but recently I came to know in the class and I talked that the students told that they don't use Facebook much now. But other side, they told that most of them use Instagram. Although I'm told that both have similar. Why I'm saying I'm told that because I don't use any of these. So you can say I am not socially networked, but well, that's partially true as far as online networking is true. I have good social networking at the physical offline level. So, but most of you are active on the online social networking platforms, Instagram, Facebook, and some of you told me that why Instagram than Facebook? Why more popular than Facebook? So some people told, I'm not sure whether true or not, why more popular. The reason being told that probably the concept of liking, disliking. One, I was told that user interface is easy, better user interface than Facebook. And secondly, I was told that the corresponding algorithms for like, dislike, etc. probably they work better, like, dislike, etc. Better in case of Instagram, and more relevant results come for the searching or for the corresponding liking, etc. I'm not sure, maybe whatever true, but yeah, did you ever bother that how this all is done, how this software works? Ultimately, it's a software. How this software works? Of course, you must be talking of, so when I say liking and disliking, all this, there are certain algorithms which are working. So probably we can say that Instagram algorithms are better than the Facebook algorithms. Other side, all of us are aware, probably the Twitter versus many governments, even legal battles going on, including in India also. We have certain issues earlier in the past and even legal battles going on. And sometimes uh, Twitter claims that they don't have algorithms available for stopping something or for controlling certain things. So they also face certain algorithmic issues. Well, if they are saying a truth, still there can be algorithmic issues. No algos available for controlling whatever they needed, which is illegal or which is not allowed by the government, to control many aspects, to control abusive or certain non-expected or non-government, non-permitted contents, to control these things, or even to identify certain things. So there are definitely going to be bigger algorithmic issues. Well, ultimately, algorithms directly work over the storage, directly dependent over how do you initially manage your data on the storage and management of the data. So did you ever bother that how this all data is being stored? Storage and the management of the data ultimately means you are going to have certain data structures for the storage of them. Well, if you talk of storage like array-based storing, so I'll say on Instagram, I have millions of users probably, and they have then billions of connections, etc. And then there could be lots of messages, and every day the data being data being generated, certain media contents, message contents, and then there are going to be billions of connections also. So can array really work? Not very sure. Can linked list really work? Not very sure. Obviously, you can think of trees never going to work because I don't have a hierarchical relationship. Tree are primarily stable whenever we have a hierarchical relationship, when I have a parent-child relationship. In social networking, you won't be really happy to have your parent and child being connected on the social networking. So you want to be connected with the friends, not with your parents. Maybe some of you will accept the friend request of the parents, many of you will not. Well, that's all fine, perfectly fine. Your likings and dislikings, you have the whole priority. But ultimately, what I want to say is that, of course, these data structures might not be suitable. Then which structure is being used? Did you ever think? Yes, many of you could have guessed probably correctly that the data structure used for all of these has been probably graph and extensions to these. So there are even graphs extensions, multi-graphs, and etc., etc. But yes, a graph is a primary data structure which is used for storing, because there is no hierarchy and there are going to be people and connections among them. So I say maybe each individual user or people, they become a kind of a vertex, and connections among them, say if I am friends, say friends, etc., they become the edges or some similar kind of a connections. So all that can become a kind of a graph. So mathematically, when I say graph, mathematical definition we will know, and then we will go to programming aspect. Mathematically, graph is nothing but it's a collection of a two that sets. I say V is set of vertices and E is a set of edges. So mathematically, it is a set of vertices and set of edges. Mathematically, set also means it is unordered. So ordering doesn't matter in whatever order these data are stored. So mathematically, I can say this. That means generally from programming viewpoint, we will have the vertices numbered as a 0 to this. So if I assume, let's say some graph like this, 0, 1, 2, let's say 3, maybe 4, maybe 5. So I have some graph, let's say like this. Something like this. Let's assume I have a graph like this, sample graph. So mathematically, I can say G means effectively I have 0, 1, 2, 3, 4, 5, 6 vertices. So this I'll not say G, I'll say this is V. And E means I have certain edges. 0, 1 being one edge. I'll just use a different notation. So I'll say 0 being one edge, 0, 2 being another edge, 0, 5 being another edge. Similarly, 1, 2 being another edge, 1, 4 being another edge, and 2, 4 being another edge, 2, 3 being another edge, and maybe 3, 5 being another edge. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So 8 edges, 6 vertices, and 8 edges. This becomes mathematically this particular graph. So I say this is my graph. So this is how it will be stored. Similarly, so now imagine if you have your social networking Instagram. So you have various users. So millions of vertices will be there. And then there can be accordingly connections between them. So millions of vertices. Of course, you require a lot of good storage, a lot of good data storage, and then good efficient algorithms to process, have all likings and all that, friendships, direct friends, indirect friends. So all those kind of a thing, direct and indirect friends or friend of friends, like that. When you get in like LinkedIn, you come to know that you are connected to this person is connected to this. So this I say first connection, second connection, third connection. So all that effectively now you can see is going to be something related to graph processing. Third connection. So effectively, it's all graph related processing, graph algorithms. So we need to really know a lot of these, and we are going to study in detail all of this. So it's all mathematical. Programming wise, of course, now programming wise, we have to implement. So there are going to be certain ways of implementation. So I say, and before that, if you see here, the edges 0, 1 automatically also mean a connection 1, 0 also. So this is currently undirected graph and edges are undirected. There can be directed graph also, and a directed graph will mean that edges will be directed. Edges will be directed. Of course, directed will mean that I will have, say, from 0 going to 1 means one edge, but it doesn't mean 1, 0 also. Does not mean a connection 1, 0 also. If 1, 0 exists, it will be separate. Or maybe, let's say I could say, instead of this, I have, say, 2. This exists, but 0 to 2 doesn't exist. 2, 0 exists. So in this case, my vertices are 0, 1, 2, but edges are 0, 1. Then I have 1, 2, and then I have 2, 0. Similarly, there can be a vertex like 2, 1 also. But 2, 1 has to be separately existing. 1, 2 doesn't mean 2, 1 at all. Now, when we will use a directed graph, when we will use undirected graph, of course, question to question, it will vary, problem situation to situation. But for example, I say friends. Normally, friends, I can say it's undirected. Undirected friends. Why? Normally say if A and B are friends, we say A and B are friends. We don't say A to B is a friend or B to A is a friend. So normally it is undirected. Yes, sometimes you could have those kind of a relation that you treat someone as a friend, but other person doesn't treat you as a friend. Well, that's probably in the physical mode, probably at the beyond online. So in online mode, you say A and B are friends, or A and B are having a friend request accepted. So both are friends to each other. But sometimes there can be some other relations can be one way also. Some other relations can be directed also. Maybe you can think of certain situations. I'll share with you certain live situations. Maybe at your time, you might not be aware, but maybe at least 25 years ago, or maybe 20 years ago, in colleges, there used to be so many fights. So in REC or in Kurukshetra University and many other places, there used to be that one boy has beaten another boy. And suddenly, when inquiry was held, asked why. So the second boy has no idea why he is beaten. He has no idea why I am beaten. Then first boy is called that why did you beat him? So after certain discussions or after some time when he opened up and he told that I have beaten him because he is trying to become closer to the girl I like. So now it was effectively a love issue, love triangle. So I'll not say love triangle, but love related issue, love or liking. Suddenly, then the girl is called and asked that what is the issue? Whom do you like more, or what is the issue? So girl was surprised. She said, I don't know any of these two boys at all. So that was a one-way liking or one-way love. So 25 years ago or 20 years ago, it was one way always, most of the time in the colleges, or one-way love. So it was a directed relationship. Yes, scenario has changed in last 20 years, but still one way liking still continues and all those things do happen. So it's a directed relationship that. So I can't say that if A likes B or A loves B, it doesn't necessarily mean this also. Might not be true. So sometimes we have to store directed or sometimes we have to store undirected. So based on application, we will be deciding that which one to be used. Directed versus undirected. And that is the whole purpose of learning your data structures and algo, that you have to apply all this knowledge for solving problems, for solving applications, apply to real life applications, real life questions, real life problems. So that is what is the whole purpose of learning all these. So your real life situations and domains will be given to you and you have to identify which data structure to use, which algo to use. So coming to programming aspect now, I'll say from programming viewpoint, there are effectively two storage for this graphs. One is called as adjacency list, or I'll say adjacency matrix. And second is called as adjacency. And second is called as adjacency list. As the word suggests, it's a kind of a 2D matrix. It's a kind of a linked list. We will go one by one. So let's go for adjacency matrix. Adjacency matrix simply says if there are n vertices, I will have a 2D matrix of n into n size. 2D matrix of n into n size, storing adjacents, storing information about adjacents. So that means effectively, let's say n is, let's say in the previous case, 6 for the previous graph. So I will have a 6 into 6 matrix. 6 into 6 matrix means 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So 0 to 5 this side, 0 to 5 this side. And here entry ij will be equal to 1 if edge ij exists. So that is what adjacency matrix mean. So effectively I mean row 0 shows adjacence of vertex 0. For example, above graph, if I see 0 has adjacent 1, 0 has adjacent 2, and 0 has adjacent 5. Then in this case, I will say 0, 1 will be 1, 0, 2 will be 1, and 0, 5 will be 1. All others will be 0. Of course, because it's an undirected graph, then for node 1, let's say for node 1, I say 1 has adjacent 0, 1 has adjacent 2, and 1 has adjacent 4. So 1, 0 is also true, 1, 2, and 1, 4. So then corresponding to 1, I will have here 1, 0, then 1, 4, and I had 1, 2. So 1, 2 means this. This is node 2, this is node 4, and 5. So effectively, in this entry is going to be 1, and similarly for all. So you can see primarily my diagonals will be mostly 0, diagonal elements, because they will be effectively representing I. So this will be mostly 0, in most of the applications. But if a self loop exists, then this entry can also be there. If a self loop in some question exists, then I can have this. For example, I say there is a node 0, there is a node 1, there is a node 2, and from 1 to 1, there is one loop available. So I can have entry 1, 1 as 1. But again, it's application specific. Most of the time in a graph, I don't say that I am friend to myself. So for social networking, this will be rarely used, but in some situations, even self loops could be used. But otherwise, diagonal elements will not be much useful. And if it is undirected graph, I can easily see undirected will mean it will be symmetric in nature. Symmetric, I hope you remember, will mean that whatever are entries into the upper triangular matrix, the same will be available in the lower triangular matrix in the vice versa. For example, if this is there, that means this one will also exist. So I will have effectively all those, this one meant effectively, this is 1, 2. So 2, 1 will also exist. This is 0. Let me just correct that. So I have got that this one will mean this entry existing. This one will mean this entry existing. So transpose of the two matrix will be same. Transpose will be same. Same as original. So in case of an undirected graph, it will be true. In case of a directed, obviously not. Having said that, so let's think now how we will implement. First thing is, if I'm talking of this values to be 1 or 0, so I can easily take it as int or bool. Say I declare int graph 1. Normally, you are supposed to declare here a bigger size. So maximum n can be 20. If you want more, you can have. But imagine now, if you are talking of Instagram, etc., then you have millions of users. So n is millions, and obviously you require a big space, n into n. So obviously I can see might not be a good choice. But yes, this is one of the easiest way to implement a graph. So other way you could have done is that you declare int n, and then you say, I will have a scanf or C in, and then you will write int graph 1 nn. Well, yes, might work initially, but some of you might not be aware that if you do like this, passing it as a parameter can create many problems. Passing it as a parameter to a function like this, you have to be careful. Can be problematic because if you write there, like if I have some function void function fn1, and here if you write here int graph 1 like this, syntactically, sorry, like this, if you write all empty, there's nothing special, nothing specified, and maybe int and etc. written, then this is not acceptable. Maybe you get some syntax error. Then you try to write here probably something like int graph 1 nn, again might have certain issues. And if you write like this, so you might have certain issues. And then maybe you will write something randomly to compile and then do, but your code can fail, code or results can be incorrect, and you will never come to know why they are incorrect. And why? No idea. So if you do not know what is the meaning of this n into n, how it will work, that is all going to play a role here, especially accept first size in any multi-dimensional array, except first size, all sizes have a role to play. All sizes are crucial to be passed and useful during parameter passing, for parameter passing. So effectively, if you pass incorrect size, then it will be a problem. So if you are not clear, if you have not done this well in C programming, etc., maybe you revise that. But otherwise, that simply declaring it as int graph 1NN can be problematic, especially for modular programming. So modular and parameter passing, you will face problem through this until unless you know how to enter. So modular and parameter passing issues will be there. You should know those issues, only then you use accordingly. Otherwise, you don't use. For the time being, initially, you can start working it as int graph 1, let's say 2020 or 50-50. You can easily have, say, something like this, 2020, or even if you want bigger, 50-50. And then when you write function, if you write void function 1, you can here simply pass int 1 graph 1 as 2020, and this will work perfectly fine. And plus n you can pass for your programming, and this will work perfectly fine. Or you can also write fn1 int graph 1 first size. Even if you don't specify syntactically, this is acceptable, but this size you have to give. And that is why I said this is important. If you pass here n, this can be problematic. And then you will face certain problems which you are not. So all this you have to handle. So for the time being, I assume this. And as we said that we will always focus on programming using modules, and parameters will be needed. So int graph 1 2020 declared, and then now you have to read your graph. So graph 1 becomes a matrix of size 20 into 20. So the first operation which I need is read a graph. So normally graph can be read in two ways. Method 1, I will go. So you ask the user has to input the adjacency matrix directly. So he has to prepare adjacency matrix and you read it as a graph. And programmer, what you do is read a 2D matrix, read a 2D array of n into n. That will mean effectively you do nothing special. Say you write for I is equal to 0, I less than n, I plus plus. Similarly, you write for j is equal to 0, j less than n, j plus plus. And then effectively you write scanf %d ampersand graph 1 ij. But that will mean the user has to create this graph of its own, which is not a good method. We are expecting user to do too much. Other method is, so I'll say method 2 for the read graph itself. Method 2, which is more useful and helpful to us, can be that ask user the adjacents of each node and accordingly store adjacents of each vertex, and rest everything you handle yourself. And you as a programmer, programmer prepares the adjacency matrix. The adjacency matrix is prepared by your program. Means what? I will say, ask the user what is n. So user says 6. Then you ask, okay, for I is equal to 0 to 6, I is equal to 0, I less than n, I plus plus. And then you ask, enter adjacent vertices of node I. Adjacent vertices of node I. So for use, say user gets, for I will mean effectively you will write %d, and then I will specify as this. Now, once you say zero, I said when I is 0, I am given the message enter adjacency vertices of node or vertex 0. So user gives input, say 1, 3, 5, and let's say -1. So -1 will mean that is the last value. This should indirectly mean that in my graph 1, I am supposed to do programming where graph 1, 0, 1 is treated as 1, graph 1, 0, 3 is made as 1, graph 1, 0, 5 is made as 1, and -1 to terminate my input for the corresponding this particular vertex. Similarly, then I will go for I becoming initially 0 was there, then it will become 1, then it will become 2, and so up to 5, and you will read all adjacents. So that will effectively mean using method 2, adjacents are asked from the user, and your graph 1 or your adjacency matrix is entries you do yourself, entries through your program. So that will be a better method, and you will be able to prepare that. So method 2, I said this was method 2 based, and preferably this is better method obviously than the first method. So you will use this, and you can definitely do programming based on that. Now, once you have read the matrix, we have to do certain operations. And effectively, operations mean your 2D array processing. 2D array processing only. So whatever matrix processing you want to do, you can do effectively. Effectively, now it's 2D array processing. For example, let's say I want to count total number of edges in the graph. Total number of edges in the graph. How to do that? So effectively, you have to have a counter, count equal to 0, and then you can have a for I loop, you can have a for j loop, and if your entry ij is equal to 1, then effectively you do count plus plus. That's it. This becomes a simple operation. Similarly, let's say I want to find out the vertex having highest number of outgoing edges. So I am assuming, let's say, the directed graph, and a directed graph will mean outgoing and incoming will be there. So assume the directed graph for the time being. Of course, similar works can be done on an undirected graph also. So assuming that I am talking of a directed graph, I am doing these operations. Vertex having highest number of outgoing edges. So effectively, you have to do for each vertex, you have to count outgoing edges, and outgoing edges effectively mean row-wise you have to process. So effectively, row 0 shows outgoing edges of vertex 0, outgoing edges of vertex 0, and similarly, row 1 means outgoing edges of vertex 1, and so. So effectively, you have to find the count of each row and then find the row having highest count. So effectively, you have to find the row number having highest count, having highest count of ones. So that will become your logic. Again, it's a simple array processing. Let's talk of some other operation. So I want, let's say, operation 3, find vertex. And I'm saying find vertex having outgoing vertices to all vertices having, say, connection, or I'll say outgoing connection. because I'm talking of undirected, incoming will be also separate. So having connection with all other vertices. So again, effectively for each row, you have to check if all values, all ij except diagonal, except I'll say, if all ij entries are 1, then it is the answer. This vertex is okay. Vertex to be printed. And the same to be done for every vertex. So again, another array processing. So effectively, this will be my logic. You can easily implement that. You have to try and do all these implementation at your hostel or home before the next class. So next operation, I'll say find, maybe now I say find the vertex having minimum incoming edges, minimum count of incoming edges. So I'm talking of incoming now. So now this becomes a different operation than others, but incoming edges, effectively, it will mean that you have to do column-wise process. So you have to go column-wise. You have to count each columns because a column show incoming edges and rows were showing outgoing. So I can easily count this count versus other count, etc. And then find the minimum one. And then accordingly, I can say that will be the minimum count. So now it will be column-wise processing to be done. And effectively, I will find that. Maybe I'll take off another operation. I want to find the vertex which is completely unconnected. Find the vertices. There can be many vertices which are completely unconnected. Completely unconnected means in a graph, there could be some graph like I have, let's say 0, 1, 2, 3, 4, 5. Maybe I have connections like this, 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 connection like this. But vertex 3 is totally unconnected. Vertex 3. Unconnected, totally unconnected. So how to find that? It automatically means no outgoing edges as well as no incoming edges. So probably you have to do the processing through programming in the both directions. So programming wise, first say you will go row wise. From row wise, you will find certain vertices. Process row wise. If any vertex found having 0 connections, maybe immediately in any vertex, or I'll say any vertex found having 0 outgoing edges, it might be possible, but I'm not sure. If found having 0 outgoing edges, I will say, let's say vertex, some vertex K found, then immediately I will say, check row or column K, whether it has for incoming edges. So effectively, once you find certain K satisfying row wise, then you have to check column K for 0 incoming edges. Similarly, whenever you get any K, you have to do that programming. So that can be again programming for this operation. So you can implement all this. Easy programming at present because not much difficult logics needed. And array otherwise also easy. Generally, array is easier to program and can be faster because you can reach to any index. And faster also many times as going to any index ij is unit time. Any ij you can reach. say as any element ij can be found or can be reached in O1 time. That is the advantage. So try all this. If there are any doubts, maybe next class you can ask me. But then going to a better storage or better method of a storage for the graphs, which is called as adjacency matrix, adjacency list. That is called as method second alternate, which we call as adjacency list. Reason is obvious, like in Instagram, if you have millions of users, out of millions of users, millions of nodes will be there. So n will be millions directly, but for each n, are we going to have millions of connections? How many edges we expect? Say, if you have a lot of friends, maybe you will have few thousands on average, or few hundreds, like that. So you are going to have, each person on average is going to have maybe outgoing edges or friends, etc., few hundreds or thousands, except few celebrities, etc., or big person. But otherwise, on average, you will have maybe few hundreds, sometimes few thousands. But that will effectively mean many entries in adjacency matrix will be zero, because out of millions, you have few hundreds and thousands as non-zero, otherwise many entries as zero. Like if I say row 0, it has millions of total entries. And out of this, all these have a very few ones. Similarly for the row 1. So if you have adjacency matrix, the n into n will be big array having few entries as non-zero, and obviously that will make the whole programming time also many consuming, and we will be wasting a lot of zero-based processes. So effectively, adjacency matrix doesn't suit for big N. It will not be a suitable choice. Adjacency matrix is not good at all from both viewpoints, because efficiency of the storage space will also be poor, and efficiency of the algorithm, because every algorithm will be n into n time processing, n time processing. So array adjacency not preferable, not useful much. Then we go for adjacency list is more common. So most of the time, this adjacency list is used. It means effectively it is array of linked lists. For example, I say for each vertex, what we will maintain is list of adjacents will be stored. Adjacents. I'll say linked list by effectively. But linked list means only those nodes will exist which have a non-zero value. Only those nodes which are adjacent will be stored, other need not be stored. Effectively, that will mean for n equal to 6 graph case, I will say that if this is my storage, each of this is my 0, 1, 2, 3, 4, 5, and 6. So for this, I will have adjacency list. For example, I say 1, 3, and 5. I said that 1, 2, and 5. If I remember, we had 1, 2, and 5. Let's just see. Yeah, so we had for 0, 1, 2, and 5. So we will store here correspondingly 1, 2, and 5 as its adjacents. And because the list is ending, so I will have here null. Similarly, for row 1, let's say I said I have its adjacent as a 0, adjacent as, let's say, 2, and similarly, if any more, otherwise, maybe I'll say null, etc. Maybe certain node, if, for example, I said node 3, if no adjacent, so it will be null effectively. I'll say it will be null directly if no adjacents. Now you can easily see, even if we have millions of users, for each of them, one adjacency list has to exist, but the list will be usually small, few hundred or few thousand entries. So this becomes a better representation. Programming wise, how we will declare, obviously, because we have a linked list, so I will require a node to be declared. So I will say I will have a type def struct, say some node, say I say graph node, G node, or graph node, whatever you say, and type def will help me in the long run. So I will say int, say vertex, adjacent vertex, or any vertex number. And I have a next pointer struct G node and star next, as we have that node available to us. And then, of course, I will write here G node. It becomes a data type available to me. And then now I have to declare my graph 2, or I'll say adjacency list representation. I want graph 2 to be, graph 2 will be now array of pointers. So graph 2 means adjacency list graph. I'm using this word graph 2. So it will be, graph 2 will be effectively nothing but it will be always array of pointers. We have just seen that we used it as array of pointers. How to declare graph 2 to be as array. So this is the first thing to be done. Of pointers, pointers to whom? Pointer to node. If I have pointer to int, I write int star, say some variable f1 20. It means f1 is array of pointer to integers. And here I want G node star. So this becomes graph 2 is array of pointers. Graph 2 is array of 20 pointers, this being array 0, this being array 19, and each is pointer to node type. But this list doesn't exist. So adjacency list will be dynamically created, to be created using malloc, for any number of nodes, and like this. So remember, whenever you declare this, even if you write it as a G node star here and then gap and like this, or you write it as a G node here, you write here star graph 2, it is one and the same thing. Both are same. Making a space here or making a space here doesn't make a difference. Reading or declaration always means that you will start from the variable name graph 2 is. Now what is graph 2? Out of a star and scare bracket has more preference, more precedence. So I will say graph 2 is an array. Scare brackets mean array of 20 elements, where each element is of what data type? Whatever is remaining on the left side, that is considered as data type. So left side is your data type, and this you could say will mean the corresponding data type to be pointer to G nodes. So this is all how we read. So my all variable declaration will be done like this. So once I say I have declared G node star graph 2, even if you put here again space, what you got is this structure where each of the pointer is pointing to some garbage address. Remember, this address is at present garbage. Each pointer address is a garbage address. So you have to accordingly manage, but precisely you have got 0 to 19 pointers. So then you can read n. So reading method 1, use the same method. Method 1, maybe if you read adjacency matrix from the user. But if you read adjacency matrix, that means you have to declare this. Declare extra. So declare one 2D array also. And then from this 2D array, you will find all entries of 1. And accordingly, you will create nodes in each respective adjacency list. In each respective, I'll not say each, I'll say in respective adjacency list. For example, you are given a matrix like this. For row 0, you have got entry at 1, entry at 2, and then this entry doesn't exist, this entry doesn't exist, and then you have entry at 5. So 5, 2, and 1. So first of all, this whole to be read. Based on this, you will say, now this entry where I have got this garbage address, this will be changed. First time I will create node 1. Then I will create another node and link it with the previous node. Then I will create another node, link it with the previous node, and then I'll say it is null. So effectively, what it means is graph to 0 is linked list of adjacents of vertex 0, linked list of adjacents of vertex 0. So this is effectively, it means a start pointer of this linked list. And same is true for everyone. Graph to 1 will be another linked list. It will be equivalent to start pointer of this linked list, and so and so. Once done, rest is effectively your array or linked list processing. All operations will be now based on the same work. For example, I say, or before that, I will say, once I have done this, let's understand with the storage method 2 also. So storage method 2 was a more appropriate method. As method 1, we have already seen method 1 is really inefficient, unnecessary. We are wasting a lot of space by creating a 2D array. Method 1 is inefficient, so obviously not useful. But yes, sometimes you are given one corresponding adjacency matrix and you have to convert that to adjacency list. So you should know how to do that. So, but method 1, I say inefficient, and this method is used more frequently. Again, so this is a more commonly used method. Adjacency list is more commonly used, and this is storage used. So for example, you will ask adjacents of vertex 0. You will ask initially, he will say 1. So initially you had an empty linked list or you have a garbage. So you will say it was empty linked list effectively. You can initialize it with a null for the initial base. And then one by one, you get one node, you add this. Then user says adjacency of vertex 0 is a 2 also. You get another node. Then he says it has 5 also. You say add another node. Then user says now it is -1. So you say terminate it with null. Similarly, then you go for vertex 1, adjacents to be read. Vertex 1, it says 0. If it is undirected graph, for directed graph, accordingly 0 given, let's say 2 given. So I will say 0 given, 2 given, and so on. So, and it's same process you will continue for all nodes. So no extra 2D array needed, and you can still do all this in this manner. So now, say operations, same operations, all 5 operations, let's say we discussed, go one by one. Count number of edges in the graph. Effectively means for each adjacency list, you have to traverse and count. That's it. So you have to effectively say for I equal to 0, I less than n, I plus plus, and then you will say effectively graph to I, and maybe you can say traverse and count. This is a linked list. So effectively linked list traversal logic or function you have to write. Simple. And that you keep on repeating, and then accordingly, maybe you can say return it as a C1, and then you can say count equal to count plus C1, and then count you can use count as initially 0, and then keep on doing that. So you can simply have logic like this, count equal to 0, let this return the total count of the traversal, or straight away write logic here. Need not be a function, direct logic can be written here. No need to have a function here. So direct logic can also be written to count and traverse. So anything you can do. Method 1, first operation 1. Operation 2, let me just have this storage and just have 1 or 2 more slides added. So I'll just say add slides, new slides. I'll just revise and then come back. So I said this, operation 1, similarly operation 2. If I'm talking of operation 2, I said, say operation 2 said to me vertex having highest number of outgoing edges. If I say directed graph, vertex having highest count of outgoing edges. Again, effectively, you have to count length of each adjacency list, and you can easily do and find highest. Not a big deal, you can easily do. Similarly, for operation 3, we had vertex having outgoing edges of all vertices. Again, that also you can do in the similar manner. But let's talk of 4th operation mode, which said vertex having minimum incoming edges. Vertex having minimum incoming edges. So now, earlier we could do column processing. Now no column processing is possible. So this is to be handled carefully now. How to do that? So I will say effectively row wise, or I'll say adjacency list wise only I have to go. Adjacency list traversal wise only. So what I will do? For example, I'll say corresponding to this, I will start from the vertex 0. I find vertex 1 is connected. So I will maintain incoming counter. Let's say incoming counter. Initially taking incoming counter to be 0 for every nodes. Let's say this is initially 0, 0, 0, 0. And because it's vertex 1 has 1 incoming counter, so I will say this to be incremented. This will mean this to be incremented. Then you have, let's say, vertex 2. It will mean this to be incremented. Then you have vertex 5. I'll just correct this. say initially I have vertex 1, then vertex 2, then vertex 5. So 2 will mean that now I have to increment this plus 1. 5 will mean I have to increment this is null next. So this will mean increment this 0 plus 1. After 0, let's say I have vertex 1 corresponding to vertex 1. There are certain outgoing edges. Accordingly, those counters to be incremented. So effectively, you might have an array of counters for incoming. And accordingly, you will traverse every adjacency list and use this counter to be incremented. And then once array ready, then later find the minimum count. Of course, if I'm talking of a directed graph, then accordingly you have to be careful that your storage is according, your processing is according. Similarly, for the fifth operation, we said find unconnected vertex. Now, unconnected row-wise processing was over, easy, but incoming connections, again, I have to be careful. So whether it has an incoming connection or not, again, not straightforward, not straight in a single step, not a single step. Earlier, it could be done with a single step by going to that column. So of course, when you use linked list, it has its own disadvantages also for certain situations, but we can't afford millions of 2D arrays. So million into million will be impossible. So do this. So homework for you, read directed graph using both methods. Both methods which we have discussed. One first, then I'll say for a directed graph using adjacency matrix, implement all 5 operations. So read through any method, and then once your graph is ready, implement all 5 operations. And maybe some more operations, whatever you can think. For example, I say find friend of a friend, say find indirect friend of someone, of say vertex K. So I'll say implement 5 operations plus this. Similarly, then third, I say same to be done above 2, that is above question to be done for adjacency list also, using adjacency list representation. So of course, you will get a lot of practice, and through this, your clarity of the graphs will happen. Once that is there, the next class, we are going to do some more useful operations. So before next class, please prepare all this and complete before coming to the class. Thank you. Bye-bye. You must do all this before coming to the next class. That will help you in understanding next class in a good way. All the best. Must practice all these, implement this and run and test.